Hello everybody, myself I am Vaishali. I am going to deal with the course of Database Management System, which is BSc Fifth Sem paper, in which I am going to deal about the third unit, the Relational Data Model, and this is the module outline which I am going to tell, in which I am going to discuss about the various integrity rules followed by the various relational set operators. Let us now discuss about them in detail. Coming to the first one, integrity rules. What are the integrity rules? The relational database integrity rules are being used to determine they are being used for the database design. For the database design, we have to definitely maintain the relational integrity. So the integrity rules are being used for the design of the database. They are being used when designing the database. If we are going to design a database, that database must be designed in such a way that we have to satisfy these integrity rules. A database is being defined or being abided or being developed based on these integrity rules. So RDBMS enforces these integrity rules. If we are going to define a database, definitely relational database management system should enforce these integrity rules or should be used these integrity rules in order to define a database. That is, if I am going to define a database, that database which contains number of tables, it should be defined based on only these integrity rules. And these integrity rules are being divided into two categories, which include entity integrity and the referential integrity. These include entity integrity and referential integrity. Let us now discuss about each of them in detail. So first one, entity integrity. What does an entity integrity define? So what is the requirement of the entity integrity? All the primary key entries are unique and no part of the key is left null. All the primary key, if I define a particular column as a primary key, that primary key column should always maintain unique values and should not contain any null value. Suppose in the table, if I define S number as a primary key, that S number should always maintain the values which are unique. That is, no value is repeated and also it should not contain any null values. Each row is being identified uniquely. Each row has its unique identity. If I take student number 2, with the help of student number 2, with the help of that number, I can get his name, address, phone number, etc. Like that, it should that particular column, it should always maintain its uniqueness. At the same time, the foreign key value can be properly reference the primary key values. In the primary key, for example, is number. In the S number, if I consider it as a primary key, in the S number, I will be having some values. For example, I have 1, 2, 3 as S numbers. So, if I am going to use this S number in the lecturer table as a foreign key, then in the lecturer number also, I should have the student numbers as a 1, 2, 3. But not the other numbers which does not exist here in this table. That is called as a referencing. So foreign key contains or foreign key values can be properly referenced the primary key. In the primary key, whatever the values are existing, such values or those values should only be used in the foreign key. For example, no invoice can have duplicate values or null values. That is, no column should have duplicate values. A column, if I define a particular column as a primary key, that column, it should not contain duplicate values as well as it should not contain null values. Invoice, if I consider invoice as a column, in that invoice, we should not have duplicate values as well as I should not have null values. Also, the invoice values should always be unique. In the invoice, I should have the values which are always unique. I can identify them with their invoicing number, which can be identified by the invoicing number. All the invoices are uniquely identified by their invoicing number. With the help of invoicing number, I should be able to get all the details. All the invoices are uniquely identified by their invoicing number. All the invoices are being in the invoicing table. Everything is being identified with the help of invoicing number. This is entity integrity. The next one is referential integrity. And in the referential integrity, what is the referential integrity? What is the requirement for defining the referential integrity? What is the requirement purpose? A foreign key can have null entries. So suppose if I use the invoicing number, if I use the student number from which is a primary key of the student table into the lecturer table as a foreign key, then what are the rules to be remembered or what are the things to be remembered when I am going to use one table primary key into the other table as a foreign key? Some points are to be remembered. What are those? A foreign key can have null entries as long as they are not of its table's primary key. A foreign key, for example, student number, it can have null values, where in the lecturer table it can have null values. But if it is that S number, if it is in the student table, there in the student table it should not contain null values. But as that S number is being used here in the lecturer table as a foreign key, there it can have null values, because it is not a part of the primary key in the lecturer table, because S number is not a part of primary key in the lecturer table. Every not null foreign key must reference existing primary key values. Not null foreign key must reference existing values of the table. That means here in S number, if I define in the student table, in S number column, if I define 1, 2, 3 as S numbers, those numbers can be used here in the foreign key. Not existing values should not be used. It is not possible for an attribute. It is possible for an attribute to have corresponding values, but it is not possible to have an invalid entry. Means in S number of the student table, I have 1, 2, 3 as S numbers. Those can be used here in the lecturer table as a foreign key. They are valid entries. But instead of 1, 2, 3, here in the foreign key, if I use 4, 5, 6, it is not a valid entry, because 4, 5, 6 are not the primary keys of the primary. They are not defined here in the primary table. Such entries are not allowed, and it is called as an invalid entry. It is not possible to delete a row in one table whose primary key has mandatory matching foreign key value in the other table. For example, in the student table, if I define S number, in the S number column, 1 is defined as a primary key, and that 1, it is being used in the lecturer table as a foreign key. In the lecturer table, it is being used as a foreign key. Then we cannot delete that particular row from the lecturer table. In detail, we'll discuss about that gradually by taking with an example in the next slides today. For example, consider a customer might not yet have assigned a sales number, but it is impossible to have an invalid sales number. If, for example, I am a customer, I have visited a shop, I went and visited a shop. So as soon as I go to a shop, a salesman will be coming and asking me what do I want. So if I go into the shop, if no one comes and asks me what do I want, that means that I am not being assigned any number. So then in such cases, I will not be given any customer number. Not to worry a lot about this example, because in the next slides, we will be discussing in detail about this example. So now consider two tables and a example of entity integrity and referential integrity is being shown here. These two tables. The first table is the customer table, in which the primary key is the customer code and the foreign key is the agent code. And in the second table, I have the table name as agent with its primary key as A code. If we look over the table, the customer table has the fields customer code, customer name, customer initial, phone number, customer insurance type, customer amount. This is the customer details, followed by one foreign key in the customer table, that is A code, agent code, to which agent is the customer paying the details. So now coming to the second table, agent table, in which we have the fields A code, agent number, A phone number, agent last name. These are the agent details, in which A code is the primary key, and this primary key is being used into the customer table as a foreign key. If you look over there in the diagram, I have representing an arrow in the upward direction, which indicates that A code, the primary key of the agent table, it is being used into the customer table as a foreign key. Now let us discuss with this example entity integrity. So in the customer table, the primary key is C code. In the customer table, primary key is C code. Customer table, in the customer table, customer code is the primary key. So if we look over the customer code has no null values, and all the entries are unique, and they does not have any null values. So C code is defined as the primary key. In a similar way, in the second table agent, A code is called as primary key, because it also is maintaining unique values, and also it is not containing any null values. So if we are able to define a primary key for their respective tables in that way, then those tables are said to be maintaining entity integrity. In customer table, I have C code, which is the primary key, and that primary key is maintaining uniqueness, and it is not having any null values. Similarly, in the agent table, I define A code as the primary key, which is unique and which is not having null values. If I am able to define the tables like this, then customer table is said to be maintaining entity integrity and also agent table is said to be maintaining entity integrity. Now let us discuss about the referential integrity. So what is referential integrity? The customer table contains foreign key, A code that links both the tables. So in the customer table, I have been using one foreign key, which is being obtained from the agent table, and it is A code. And this foreign key is being used to establish a link in between both the customer and the agent tables. If we look over the example, the customer code with row 10016 ID contains null entry and the A code is not yet been assigned to that. So in the customer code, in the customer table, if we look over the customer table, the customer with number 116, he contains a null entry in the agent code. There, because it is a foreign key, there we can have null values in. The remaining A codes in the customer table all match with the agent table. If we look over the other contents of the table, all the A codes in the customer table are filled except only with the customer number 10016. So, to avoid such null entries, so we should not have such null entries. So, to avoid such null entries, the designers use a specific code called as flags to indicate that the absence of the values. Here we have forgot to put in the foreign key, I have been forgetting in one row to enter the value. Such values are being identified with a special code which is called as flags. To avoid null values, the designers have given special code called as flags which are being used to indicate the absence of values. By mistake, if we forget to write any values, so the designers here have given us one option to fill such absence of values with a special code which is called as a flag. So what is a flag? A flag is nothing but the code -99 which is used to denote a null entry. If there are any null values in the foreign key, constraint, if there are any null values, such null values are being replaced with these flags which is nothing but the code -99. When such flags are being used in the A code of the agent table, it contains -99 the value of the table. That means in the customer table, here I have left one value 116. In 116 customer, I didn't enter the agent code. There I can replace it with a flag which is nothing but -99. The integrity rules enforce the relational models are not null and they maintain unique constraint. The integrity rules are being defined that so that the tables maintain no null values and also they maintain uniqueness. The uniqueness constraint is used to ensure that there are no duplicate values. The uniqueness constraint tells us that we should not maintain any duplicate values in the primary keys of the table. The not null constraint specifies that the column should not be left empty or should not be left vacant without filling any values. This is about the integrity rules and in which we have concluded saying about the entity integrity and the differential integrity. Let us now discuss about the other thing which include the various relational set operators. With the various relational set operators and these relational set operators are being used to perform basic operations on the data that is present in the tables. In order to perform operations in between the tables, we are going to use these set operators and they are very easy to use and to understand. Relational algebra is defined for performing all these operations. In order to perform these operations, we are going to use the concept which is called as relational algebra. Before going to discuss about the relational algebra, first of all, let us know in detail what are the various set operators. They include union, intersect, difference, product, select, project, join, divide, etc. These are called as the various relational set operators and let us now discuss about them in detail. Coming to the first one, union. What does a union tells us? As the name itself tells us, it is being used to combine two or more tables. It is being used to combine two or more tables. But one thing to be remembered is when combining these tables, if there is any duplication, that duplication is being avoided. Excluding the duplication it will display only the, or it will maintain only uniqueness in the table. For example, both the tables have same attribute characteristics to be used. One important point to be remembered is that both the tables must contain same attributes in order to combine them. So consider here two tables. Two tables. What are those? Product tables. Two product tables. Here I am going to consider two product table. First product table has P code, P description and P price. Second product table also has P code, P description and P price, which include, in the first table I have two rows, in the second table also I have two rows. When two or more tables have same columns, when the columns have same names, when they share the same domain, then union is compatible. Then the union is compatible. That means then only I can perform union operation. So looking over this example, I am now going to combine these two tables, in which first table has two rows and the second table has two rows. As there is no duplication among these rows present in the two tables, if I combine these two tables, the output will be the four tables like this, the four rows like this. Combining both the two tables, I am going to get one table like this. This is union. That is nothing but combining two or more tables. If when combining, the column name should be same in both the tables. And other thing is that there should not be any duplication. If suppose there is duplication also, that duplication will be excluded. That will be skipped. If two rows are being repeated in both the tables, if a row is repeating in both the tables, one row is only considered and the second row is being skipped. That is about the first one, set operator union. The second one is intersect. Intersect. For this also I am going to consider again two tables and consider only the rows of the tables that are common from both the tables. Here I am going to display the rows which are only there. In the union I am going to combine both the tables. Here I am going to consider only the rows that are common in both the tables. In both the tables, whatever are the common, what rows which are common, those are only being considered. We cannot intersect if one attribute is numeric and the other one is character type. Both the columns should have same data type in it. If the data types varies, intersection is not done. We can intersect only when same attributes is being used in both the columns. If the attributes are same in both the columns, then only we can perform intersection. It is again represented with this diagram, in which I am going to consider F names of both the tables, in which among the tables I am going to perform intersect operation. If I perform intersect operation, what is the result I get? Look over the output. So in the first table I have George, Jane, Alfred and George again. In the second table again William, Jane, George and Dennis. So if we look over table 1 and table 2, there are some elements which are common in both the tables. What are those? It is George and Jane. So common elements are being displayed as output. That is about the intersect operation, and followed by the next one as the difference operation. What is the difference? Consider again, it considers all the rows of the tables. It considers all the rows from one table that are not found in the table. That is, it subtracts one table from the another. It subtracts one table from the other. Here an important thing is to be noted. Intersect will help us to display the common elements. Difference will gives us, what does the difference gives us? It skips the common elements. It skips the common elements and displays the elements that are present in the table 1. It displays the elements that are present in the table 1. For example, if I perform the difference between table 1 and table 2, if I consider two tables, table 1 and table 2, and I perform subtraction, then what does it do? It first considers the common elements that are present in both the tables. It just ignores the common elements. After that, it considers only the unique elements of the tables 1 and displays it as an output. So let us see it with an example. Subtracting the first table from the second table is not same as subtracting the second table from the first table. Both will not get the same as output, and first table minus second table will gives us the unique rows of the table 1. Second table minus first table gives us the unique rows of the second table. Let us again take an example, discuss over this. So the same example as intersect George, Jane, Alfred, George, William, Jane, George and Dennis. In between these both, I am going to consider difference. If I do the difference, what happens? What are the elements common in these both? George and Jane are common. So we will first skip those both. And what are the elements now left in table 1? It is George and Walfred. It is George and Walfred. That is being displayed as the output. If I do the difference between table 2 minus table 1, if I put table 2 that side and table 1 this side, then what will be the difference? The difference will be now the William and Dennis. The William and Dennis. That is the difference between, that is the how we calculate the difference when we subtract table 1 minus table 2. Table 1 minus table 2. What is the result of table 1 minus table 2? It will skip the common elements that are present in the both the tables, followed by, it will skip the common elements, and later the output will be displayed only the unique elements that are present in table 1. In the similar way, table 2 minus table 1. Common elements are ignored from both the tables, and the unique elements that are left in the table 2 are being displayed as output. This is about the difference, okay? Followed by the next one as product. Here comes the most important part to be known, product. Product is nothing but multiplication, which is here called as the Cartesian product, which is represented with the symbol into. It is also consider all possible pairs of rows and tables. Product, it considers all possible pairs of rows from two tables, also known as Cartesian product. It considers all possible pairs of rows. All possible pairs of rows. That is, the first row of the first table is multiplied with all the three rows of the second table. The first row of the first table, it is multiplied with all the three rows of the second table. Again, the second row of the product table is multiplied with all the three rows of the second table. Again, the third row of the product table is multiplied with all the three rows of the second table. Repeating again, we consider the first row of the product table and we multiply this with the second row, with all the rows of the second table. In the similar way, I consider the second row of the first table and multiply this with all the rows of the second table. I consider the third row of the first table and multiply it with all the three rows, which means that one table has 3 rows, the other table has 3 rows, then the Cartesian product will be 3 into 3, 9 rows. How many rows will I get? I will get 3 into 3, 9 rows. How many rows do I get? I get 3. This is the output which I get in 1, 2, 3, 4. If it is multiplied with 3 rows, I get 3 rows. Again 1, 2, 3, 3. Because it is multiplied with all the 3 rows of the second table, I get again 3 rows. 1, 2, 3, 2. Because it is multiplied with the third row of the second table, we will get again the 3 rows. So this is how I get the product. This is the most important thing to be known in the set operators. After that, the next one is select. What is a select? As the name itself specifies, it is being used to pick up the required information. So considers all the rows from the table that satisfy the given condition. Based upon the condition, it will be giving us the required information. It is also called as restrict. The other name for select command is also called as restrict. It considers all the rows that match with the condition. Based on the condition only we can get the rows. It is divided into 2 types, which include select all and select only. It is divided into 2 types, select all and select only. Now consider this table with the 3 columns, 3 rows, 1, 2, 3, 3, 1, 2, 3, 4 and 1, 2, 3, 2. Now in order to display all the rows, if I want to display the table as it is like this, then select all. Select star from product. Select star. Star means all. Display all the rows that are present in the product table. Will display all the rows of the product table. Select only. It displays only some. So select only the products whose price is less than 26 rupees. Select only the products whose price is less than 26. Then the command is select all the products star from the product table where product price should be less than 26 rupees. So whose product price is less than 26, those rows are only being displayed here. Will not display the light information, will display only battery and lamp information here from the product table. This is about the select command. After that, the next one is project. This is also one more important operation of the project of the set operators in the project. It is only being used to display some particular column information. If we want to retrieve only one particular column information, I can get it with the command project. It considers all the values from the selected attribute. It displays all values from the one attribute is being selected, and from that attribute it is going to display all the values that are present in this selected attribute. What does it do? It considers all the values from the selected attribute. From the selected attribute, I am going to consider all the values, and it is being used to display only one particular column information. So project yields a vertical subset of a table. It is being used to get a vertical subset of a table. It is denoted as follows. Consider a product table with P code, P description and P price. If I want to display only P code, then I write it as project P code. What does project P code give us? Only P code information. In the similar way, project P description. What does it gives us? It gives us only P description details. In the similar way, project P price. It displays only product price information. Like that, if I want to retrieve only one particular column information, I go with the project command. After that, the next one to be discussed and the most important one in the relational set operators is join. As the name itself specifies, it is called as a join, and it is being used to combine two or more tables. It is being used to combine two or more tables. Join is the real power behind the relational database. The very important and the most powerful concept of the relational database is the join, which allows us to use independent tables linked by a common attribute. It is being used to combine the tables having a common attribute in common in both the tables. Now consider an example, customer and agent, where I am going to consider a table customer and agent. In the next slide, we are going to get the table and we are going to perform the join operation. But one thing to be remembered when performing join operation is we cannot directly perform a join operation. If we want to perform any join operation, we have to use, or it is being internally divided into three parts. In order to perform join operations, we need to perform three internal operations. Before going to discuss about those three internal operations, these joins are divided into three categories, which include natural join, equi join and outer join. Natural join, equi join and outer join. Before going to discuss about any type of join, let us learn how to perform join operation. So consider two tables, customer table and agent table. Customer table and the agent table. See how many rows are there in the customer table. In the customer table, I have 113, 114, 115, 116 and 117. 5 rows are there. In the agent table, I have 125, 167, 23. 3 rows. 3 rows I have. In the customer table, I have 5 rows. In the agent table, I have 3 rows. So please remember them. And also we have here in the customer table, I have a foreign key. In the customer table, I have a foreign key. That is the A code in the agent table. It is being used in the customer table as a foreign key. If we have like this only, if there is a link only in between the tables, then only we can perform join operation. Then only we can perform the join operation. Let us now learn how to perform this join operation. So, natural join. In order to perform join, which is also called as natural join, it is used to link the tables by selecting only one row with a common attribute. If there is a common attribute in both the tables, then we can perform join. I told as it is being performed in 3 stages. The join operation is being performed in 3 stages. What are those 3 stages? The first step is we have to perform product on both the tables. On both the tables, I need to perform product. That is, I need to perform a product operation in between the customer and the agent table. In the customer, how many rows I have? 5 rows. In the agent table, how many rows I have? 3 rows. So, product is nothing but, as we have already discussed, product is nothing but Cartesian product. If we consider customer table, the first row of the customer table, it should be multiplied with all the rows of the agent table. Likewise, if I have 5 rows in the customer table, all the 5 rows in the customer table should be multiplied with all the 3 rows of the agent table. In that way, if I perform Cartesian product, how many rows do I get? I get 5 into 3, 15 rows. I can combine these two tables. But while combining, when performing the first operation, how many rows do I get? I get total 15 rows. After getting the total number of rows, that is 15 rows, from those rows, I need to perform the second operation, which is called as select operation. From the 15 rows, I need to select operation. Which rows should I select? I should perform a select operation. Which rows I should select? I should select the rows whose A code, that is agent code, is common in both. Whose A code is common, whose A code values are equal. I should select some rows from those 15 rows. I can select some rows wherein which the A code is same. The A code values are equal. After that, what do I do? In the third step, I perform the project operation, which in this step I am going to remove or eliminate one duplicate column A code. I am going to remove one duplicate column A code. So here we perform three major steps to be remembered when for natural join. First one is product, second one is select, third one is project. Let us now see how to do this. So combining first step, product. So 113 it is multiplied with all the 113 it is multiplied with all the 3 rows. So we get 5 rows. After 114 it is multiplied again 5 rows. Again 115 5 times. 116 5 times. 117 5 times. So I get overall 15 rows in this table. I get 15 rows. If you look over the table, there are some rows which are being highlighted. There are some rows which are being highlighted. If you look at this diagram carefully, we consider a column names as a combination of both the customer table and the agent table. What are the fields in the customer table? Customer code, customer last name, customer initial, A code. First 4 columns are the customer columns, customer table columns. Last 2 are agent table columns, A code, A phone number. So if we perform the Cartesian product on these both tables, the customer has 5 rows, the agent has 3 rows. If I multiply both, I get 15 rows like this. If now I look over this table cleanly or carefully, there are some rows which I have been highlighting in which the A code values are similar. The A code values are similar. So the third row, if you look about the third row, 231, A code is similar in both. In the similar way, the fifth one, 125 is similar. After that, 167 and 167 are similar. After that, 333 and 333 is similar. After that, 125 and 125 are similar. So there are A codes which are similar. So after performing the product operation, what should I do is, in step 2, I need to select such C codes which are equal. I need to select only the rows whose C codes are equal, whose E codes are equal, whose A codes are equal. I need to select in step 2, what should I do? I need to select the values whose A codes are equal, whose A codes are equal. Such if, see here, A code and A code is 231, 125, 167, 333, 125. The similar A code values that are common for all the rows are being selected. That is step 2. Followed by the last step as project. What do I do with the project? Here a column is being repeated. So I can read, because both A codes are same, there is no need to repeat both the A codes. So what do? I skip one column. How can I skip one column? I can skip a column, I can remove a column by using the command project. So in the third step, I am going to perform the project operation, in which I am going to project one A code which removes one A code column and displays the other values as the output. This is how I perform the join operation. See, after performing the join operation, I have got a combination of the customer table and the agent table. I have got a combination of the customer table and the agent table. This is how I perform natural join. This is how I perform natural join. Followed by the next one as Equi Join. Equi Join. So it links both the tables based on equality condition. It compares both the tables based on equal to condition. In the other, if any other comparison operator is used other than equal to operation, then it is called as theta join. If we use any other comparison operation other than equal to, comparison operators include less than, greater than, less than or equal to, not equal to, like that. If we use any other comparison operators to compare the tables, then it is called as theta join. This is about Equi Join, in which Equi Join is performed based on the equal to condition. The last type of join to be discussed is about outer join. So the last type of join to be discussed is about outer join. What is an outer join? In outer join, the matched pair would be retained and any other unmatched value in the other table would be left null. Matching pairs will be obtained as well as if there are any null values in other joins they are skipped, but in this join we also get those values, leaving the values as null. Outer join can be divided into two categories which include left outer join and right outer join. There are two types of outer joins which include left outer join and right outer join. See, this is about the left outer join only. So if it considers all the rows of the table, including that does not have matching rows in the agent table. If matching rows are there, they are displayed. If matching rows are not there, those values are also being displayed, taking the values as null. Like that, non-matching pairs or not matching values are also being obtained with the help of a left outer join. If we get to the right side of the table, it is called as left outer join, and in the similar way, the right outer join is also considers all the rows of the agent table, including those that do not have the matching values with the customer table. There are matching values that are present in the customer table and the agent table. They are displayed. Apart from that, if there are any values that does not match in the agent table, those values are also being displayed here. Those values are also being displayed here. So if there are any values that does not match, if it is right outer join to the left side of the table, there will be null values. If it is left outer join to the right side of the table, we will be having null values. This is about the right outer join, and with this almost all the set operators are being concluded except one last one to be discussed, that is divide. So here we consider table A to be divided with table 2, table B. So here we consider table A as dividend and with the two columns in it, and the table B as divisor with one column in it. Consider table A as dividend with two columns. In table A we have two columns which is considered as dividend, and in table B we have one column which is considered as divisor. Now the output of these things, if I divide table A by table 2, table B, table A by table B, the result will be in code and location. In code and location, if you look over table A, there are two columns, code and location, in which code are A, B, C, D. A has 5, A has 9, A has 4 location. B has 5, B has 5, C has 6, D has 7, D has 8. Now in the second table I am going to consider A and B. A and B. Now what should I do? I should divide table A by table B. Table A by table B. If I divide, so what happens in the table B? I have A, B only. So from the table A, I skip. From the table 1, I skip C and D. C and D are skipped because here I need to divide only with A and B. Now if I look over the rows of A and B, in A and B rows, there is a common location for A and B. There is a common location for A and B. What is that? It is 5. For A and B, there is a common location in both the A and B codes. What is it? 5. So the output will be 5. So table 1 divided by table 2. Table 1 divided by table 2. In table 2, I have A and B. So from table 1, I consider only A and B values. Among A and B values, again, one thing is common in between A and B. The location that is common in between A and B is 5. So the output will be 5. This is about the divide command with which we conclude all the set operators, and this is the module summary in which we have discussed about the integrity rules, which include entity integrity, referential integrity, followed by the set operators as union, intersect, difference, product, select, project, join and divide. Thank you all.